Okay, so how is everyone today? Good? All right. So, today's the 24th. A few reminders about logistical details of the course is that I think we're like 3 weeks out from the midterm exam. Okay, so if I recall correctly, the midterm exam is on Monday night, 3 weeks from now. So like 21 days and 6 hours. Okay, so something like that. Notably, that means that it's not during lecture, right? We're all going to have to meet at various rooms. So in fact, y'all are just one of the 6 college algebra sections. All college algebra students are going to be meeting at the same time, and I'll send you a message what room you need to go to that night. Okay, I'll send you that message like a week in advance. It's just some big room. You should find it in advance, right? Because it wouldn't be good if you were at 7 when the exam is. Is it at 7? I think it's at 7. It wouldn't be any good if at 7 you were looking for the room. Good. So that being said, the way the exam, what the midterm will consist of, is there will be 3 or 4 new out of 10 exercises. So those are you can imagine it like there's 3 or 4 new like a quiz that has 3 or 4 exercises on it. The way this will work is that 2 topics will be chosen, more or less randomly. So the majority of all of the exercises that are graded out of 10 are topics that test just one. Are questions that test just one topic. So like just one thing is being tested. And so in that sense, they're kind of very pointed, very directed exercises. But for these, we're going to choose 2 topics and then make a question that concerns both of those topics. As a result, you might find those questions difficult. That's not the intention. It's just rather what's being tested is that when a single topic is being tested, that's like an analysis question. Can you understand what's going on? And then when 2 or more topics are being tested, it's a synthesis question. So you have to understand 2 or more different things. And then with those different understandings, you have to put them together to make an overall understanding. So that those are synthesis questions. So such an example would be something like given 2 circles, say, find the equation of the line through the centers. So, depending on how I give you the circles, for example, if I say that this circle has this as one of its diameters and this other circle has this other thing as one of its diameters, then, to find the centers, you'll have to calculate midpoints. Okay, so that's like one conceptual thing. And then once you have those 2 centers, if you can find them, then you have to find the equation of a line through 2 points. So that's 2 separate topics on the same question. Okay, good. And then beyond that, there will be a redo section. Specifically, if there are n out of 10 exercises, that have at that time been graded, then you can select up to n over 2 of these. So if there's 20, then you can select up to 10. You could select 0, that'd be fine. Okay, or you could just select those 3. And to remind you of how this works, so for example, we had an assignment named 053 that happened to be an in-class quiz. Now, as you know, the in-class quizzes have just one question on them, and the name of that one question is 01. Okay, and that was selected for grading out of 10, so that means that there's a grade in the gradebook named this, WEX A for 10, 053. So suppose it's the case that you did not do so excellently on that one, and you made a 3 out of 10. So that's not awesome. On the midterm, the midterm's name is mid, and there is a redo question on it named 053. Okay, so then if you did not do so great on the in-class quiz or the homework or whatever, then you need to study, and on the midterm you need to probably select this one for redo. Suppose that you study some and you get a 9. Great. Then that means that it was previously, that grade was 3 out of 10, but now it's 9 out of 10. So that's good. And do understand that your grade can go down. So you shouldn't just do this like willy-nilly, right? It's not that your grade is whatever is the best one. Rather, it's your grade is whatever is the last one. So you might wonder, how do I study? Well, there's a variety of ways. In the first place, I encourage you to come to my office. I'd be happy to see you. But at any rate, the keys for all of these have been posted. Well, are beginning to be posted. So for about half of the ones that have been graded out of 10, the keys have been posted. So you should study, come to office hours, what have you. Look at the keys. Etc. Okay, so in the gradebook, okay, you should look for all the grades whose name starts like that, WEX A 053, and you can sort the grades in the gradebook by their course order. That's the best order to do it in. Yes.
So for midterm, will those questions be labeled like WEX mid 053 so we know?
Well, can't do that. That's the quiz. Just like if you look at your WEXs, you know how they've got the big gray number right there?
Okay.
It'll be just like that.
Okay.
So, if it's the case that that 053 is a good redo candidate for you, then you'll look for the page that has the big 053 there. Okay, now the way the exam is going to look is that, there'll be a cover page, just like the quizzes, with the bubble, 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 like that. And then there'll be 3 or 4 pages, 3 or 4 exercises, and you've got to do all of these. So you must do these. Everyone does those. And then if there are 20 out of 10, then all 20 of them will be there. Okay, so then you choose up to n over 2 of these. however many there are. And so these are the redo ones. Okay, now I want to be, to elaborate on this system, besides being on the midterm, this will also be on the final, for that matter. And just for sake of argument, say on the midterm that you didn't really make a 9, you made a 6. So then after the midterm, then you'd have a 6 out of 10. Now that's an improvement, but it's still not awesome. Okay, and then suppose on the final you make a 9. That's where you end up making the 9. Then you have a 9 out of 10 on that exercise. So I want to address something, and that is that some of y'all have come to my office and or sent me emails and said something that more or less is like, man, you grade really hard, or I can't believe that you really expect me to show all that work, because I don't want to do that. I mean, I get it. Okay, so I love human beings, and one of the best things about us is that we're so economical, which is just a polite word to say lazy. Okay, that's okay, but that's I don't say that pejoratively at all. Rather, I think it's a beautiful thing, because it makes us work hard to come up with good solutions. But it also means that we don't like to write a bunch of work. So you're going to have to decide whether or not it's worth your time and points to do that, because that's how you will be graded. Okay, so only you can decide that. So you might say, well, I didn't really understand how much work was required here. Well, now you know. So knock it out on the midterm. And nothing would please me any more than to give every single one of you an A. Yes?
So for the problems, like at the beginning of the semester where you said we'd only need to show like all those steps once, do you want us to do all those steps again on the midterm and final?
Okay, right. So for example, there's a question 005. 005 was one of those ones where you had to you weren't allowed to use exponent rules, and if it said c to exponent 5, you had to write c times c times c times c times c. Okay, if you're going to do that one for redo, you must do it that way. Okay, so you must do it in the way prescribed. Yes?
But that specific situation.
I'm sorry?
That specific situation, none of the ones you require us to solve will have that situation, will it? Like the exponent rules, you have to go with.
Well, at any rate, the instructions will be explicit. So like we're doing a quiz today. If there were exponent, if it came to pass that you could that exponent rules were applicable, by all means use them today. But if you're going to redo 005, then you need to redo it in the mode of that question. Yes?
So are the exercises from our first homework to the most recent homework, or is it just you just picking random exercises?
Well, these ones are the ones that are graded out of 10. Not all of them are graded. So there's 5 sheets turned in today. Okay, those 4 and 1 more that we're going to quiz, right? 2 of those will be selected for grading out of 10. But I don't announce in advance. The reason being is that if I announced in advance, then that would skew how much effort you put into each one. Rather, I want them all to be done. So what I'm saying is that it's only the out of 10 ones that are subject to redo. The completion ones are done. Does that answer it?
I'm talking about like the stuff that we have to do, like the
These?
exercises we have to do. Like what are the problems?
Oh, it covers everything up to. We'll announce the cutoff point when we get there. So like we're going to lecture on the day of the midterm, but that material is not going to be on the midterm, and probably not the day before that. It has to be a cut. Okay, I've heard what you have to say. Oh, you grade hard, or oh, I can't believe you make me show this much work. Oh, that kind of thing. All right, no dispute. Okay, but the standard's not changing. Your questions will continue to be graded in that way. So now it's on you. If you made a 3 here because you didn't show your work, fine. By all means, make a 10 here, and then you have a 10 out of 10. Also, I want to make sure something is clear, is that your other math and science courses are basically doing the same thing. They're doing a similar thing in that they test you over this topic once, and then again, and then even one more time. So if in your chemistry class, say, they ask you a stoichiometry question, and then another stoichiometry question, say, so maybe a quiz, and then a midterm, and then a final. And if each of these are out of 10, then this sequence of events would be 3 plus 6 is 9 plus 9 is 18 out of 30 possible points. That's what this would mean in that class. But in this class, this means 9 out of 10. That's what that means. And, that's better than 18 out of 30. Okay? So there's definitely opportunity for all of you to perform quite well in the course. And nothing would please me more than to give A's to all of you. So any questions about the logistics? So when you come to the exam, and again, this is 3 weeks out, so it's a little bit out. When you come to the exam, bring a little sheet of paper that doesn't have any notes on it, no formulas, no notes, but rather has the list of all these numbers that it's your intention to redo, because it's there's no sense in memorizing some arbitrary list of numbers. Good. Any questions? All right. Let's do one more of the linear models and then go on to the next topic. Okay. So suppose there's a population. So a population of banana-flavored mechanical pencils is growing linearly. I just think it's funny to make up something that's completely ridiculous, because no population actually grows linearly. So suppose that in, say, 2014, there were 1,200 such pencils. And in 2018, there were okay, 2,456 pencils. Okay, so then find a linear model for number of pencils B for banana flavored in terms of year T. 2, find the number of pencils in 2016, so year 2016. And also in year 2010. 2010? And no, that won't work. This one needs to be 2012. And 3, when is the number of pencils $4,026. Okay. So again, we got pretty far into a question just like this, but instead of banana flavored mechanical pencils, it was something else just as arbitrary. The way that this is solved is that effectively what the story is giving you is it's giving you 2 points on a plane, and then in terms of the symbols requested, what is the horizontal axis? It'd be the year, T, right? The reason is because we're modeling the number of pencils B, so that needs to be the vertical axis. And we're modeling it in terms of T, the year. Yeah, would you? So here is a point. So this is point, what, 2014? And that's 1200. So in 2014 there were that many pencils, and then in 2018 this many pencils. So that's 2 points on a plane. It is, it's said in the exercise that this growth is linear. So we're talking about the line that passes through these 2 points. And in the end, what is desired is a formula for that line. So to do it, we have 2 points. And concerning lines, we have 2 formulas. We have a formula called the point-slope formula and another formula called the slope-intercept formula. So we can rule one of those out. Which one? The slope-intercept one. Because in the end, of the 2 points we were given, is either one of them an intercept? Nah. So probably just say, nah, we won't use the slope-intercept one. Rather, we're going to need to use the point-slope one, but that's a little tricky because, there's not a point-point formula, right? So we need to calculate the slope. The way to calculate the slope is, well, measure this horizontal change. So what's going to be the name of that horizontal change? Is it delta x? It's delta t, right? Because the horizontal axis is t. So delta t is what? Right? So that'd be 4. And then now this way. So is that delta y? That'd be delta b. And then what's delta b? Very good. So that one minus that one, and that'd be what? 1, 2, 5, 6? 1, 2, 5, 6. And as a result, writing slope is little m, we'd want to write delta b over delta t. So that'd be rise over run. So for these specific measures, that'd be 1256 divided by 4. And then does that divide evenly? So the answer is yes. And we get that the slope is 314. Not as funny as 1314, but there you go. But it's I selected that because of pi, right? 3.14. Haha. Fine. So we need to come up with the equation. The point slope formula is this, but this is not the formula that we need because it's not in terms of the variables that we're using. So how do we write the equation in terms of the variables we're actually using? Very good. So that's translated. So now it's a matter of just plugging stuff in. So b minus and then b1. So which point do you want to use? Does it matter? It doesn't matter. It can't possibly matter. So arbitrarily I'll use that one. So b minus 2456 is equal to 314 times t minus 2018. Okay. So then I can solve for b. So this would be 314t, and then subtract 633,652. And you might say that sounds like a kind of a strange number, and no dispute, but there's nothing wrong with it. Okay, then I can add 2456 to both sides. Oops. Uh, 314t subtract 631,196. Okay, so that would be the answer to part B. Part 1. So that's a linear model for B in terms of variable t. Okay, and those numbers admittedly look strange, yes? I added it, but that's negative that much. So there it is, and you might be concerned. At any rate, it's always a good idea to check, especially when you're just using, arbitrary, more or less arbitrary numbers. How do you check and make sure that that's right? Yeah, you plug in something that's known. So, I used that point, so maybe I'll plug in the other point. So in particular, I'm going to check by plugging in t comma b equal to 2014 comma 1200. So if I plug that in to the equation that I'm saying is the model, then the result should be true. Okay. So 1200 equal 314 multiply 2014. Subtract crazy number there, 631,196. Type that in. So I've typed it in there. Okay, 1200. So 1200 equal 1200. So what does that mean about that point? Does that point, is that point part of the graph? It is. So it must be, so we must have it, right? Good. So that's the answer to part 1, finding the linear model. Then to part 2. The instructions say, find the number of pencils in year 2016. So I'm gonna translate this into kind of more mathy language, and say the request is to find B when T is 2016. So in this model, there's two variables, B and T, and I'm saying find that one when you know the other one. Okay, so that's just a matter of plugging in. Okay, so then according to the calculator, that's 1828. So now, so 1828, and now I'm gonna, what if, as I was writing that down, a cosmic ray passed through my brain or something, and I had a hiccup, I don't know what, and then somehow I wrote a 7. So in the first place, it's not the correct answer, but even more, it's sort of like categorically wrong. Like this doesn't even make any sense whatsoever. So why does that not make any sense whatsoever?
Because on the graph, 2018 is only 2,456.
Right. So we have a line between 2014 and 2018, and the number of pencils is between 1,200 and 2,400 ish. So if I ask you about an intermediate time, 2016, then the number of pencils has to be an intermediate number of pencils, right? Not 7,000. That's absurd. So such a response is no good. So 1828. Again, so for this question, find B when T is 2012. Okay, now before answering the question, you should be able to tell me something about it. What should be true about this about the answer? Yeah, it's gonna have to be less than 1,200, right? It's gonna have to be less than 1,200 because we're talking about a time that came before 2014. Okay. So then B is 314 multiplied by 2012. Subtract that number. Okay, and doing that, I get the number 572. Okay, so does that seem like a reasonable amount? Yeah, that's reasonable. You might have noticed that when I first wrote that, I wrote 2010, and I said no, that won't work. That won't work, and then I changed it to 2012. Can anyone see why I had to not use 2010? Yeah, because then the number of pencils would have been negative. And then not only would I be talking about banana-flavored mechanical pencils, then I'd have to be talking about what a negative one means. There's too many problems, philosophical there. So, finally, 3. So, for question 2, it was find the number of pencils in year 2016. And I translated that to read, find B when T is 2016. So can someone translate question 3? Find what? Find T.
When B equals 4026.
Very good. Find T when B is 4026. So I want to impress upon you that these, you know, do you see that these are very similar questions? All that I'm doing is I'm swapping the one that is known and the one that is unknown. That's all that's occurring. So now the equation reads 4026 equal 314t subtract 631196. Okay, so that we can add to both sides. Six three five 222. Okay, then I can divide both sides by 314, so that'd be 635,222 over 314. Now, probably this cancels in a nice way because I made all the rest of them cancel. But before so I'll type that in the machine here. So 635,222 divide 314. Now, this is going to be some time. Okay. And I claim before I press enter, you should be able to tell me, you know, where more or less the time must fall. Where must it fall? So where with respect to 2018? It's got to be to the right. Because what we're saying is that we're talking about a time when there's, at this point, 4,000 pencils. You know, so we have to be beyond 2018 because at that time there's only 2,400. So we have to keep going. All right. So then, okay, 2023. Okay, so now I'm going to introduce one topic and then we'll have a quiz. So I just want to introduce it so it can be stewing. All right. So this equation here, x squared minus 1 is equal to 0. X squared minus 1 is equal to 0. We can view it in two different ways. Well, in a variety of ways. Another way to view it is, well, I'll do it like this. So on the one hand, you could say, I'll move that 1 over so that it looks like x squared is 1. Now, are there any things that'll square to become 1? 1 will, right? And what else? Besides 1, negative 1, right? So if you square 1, you get 1. If you square negative 1, you get 1. So sort of, you know, in that view, you could say, well, x is negative 1. That'll square to 1. Or x is 1. Okay, coming over here, I'm going to look at it like this. I'm going to say, well, I'll view that as x squared minus 1. And I'm going to write, instead of writing 1, I'm going to write 1 squared. So now that this is the difference of squares, how does the difference of squares factor? Fishing for a phrase that starts with P. That one. I promised you I wouldn't do it, right? I wouldn't make the joke. Okay, so then this factors like this. And now have a look. These two factors, we're saying that their product is 0. So it must be the case that one of them is 0. Right? Either that one is 0 or the other. So as a result, the equation splits into pieces. Either x plus 1 is 0 or x minus 1 is 0. And so then now solving these individually, this or that. So one way or the other, you come to the conclusion, 1 or negative 1. Now here's the deal. How about this one? X squared plus 1 is 0. So it's the same equation as before, but instead of writing a minus, I wrote a plus. So viewing it in the first way, we could look at it like this. We could say x squared is negative 1. Now, is there any real that would do that? There's not a real that would do that, right? Because if you square a positive real, the result's positive. And if you square a negative real, the result is positive. And if you square 0, the result is 0. So there's not a real that does that. Nevertheless, on Wednesday, we're going to insist, no, we're going to do it. We're going to do it, and we're going to see where that rabbit hole leads. So, okay, now let's have a quiz.